Hello everyone, my name is Sai Arvind and my teammate name is Dilip. Now I am going to solve the 2.4 problem from the Open Book, the module number 2 LTI systems. The given question is compute and plot the y of n is equal to x of n convolution h of n, where x of n is equal to 1 from 3 to 8 and 0 otherwise, and h of n is equal to 1 to 0, 4 from 4 to 15 and 0 otherwise. Now we have to solve this problem. We have to perform the convolution between x of n and h of n, where x of n is equal to 1 from 3 is less than or equal to n is less than or equal to 3 to 8 and 0 otherwise, and h of n where it is equal to 1 when n is between 4 and 15 and 0 otherwise. Now we can write this x of n as u of n minus 3 minus u of n minus 8, n minus 9, and we can write this h of n as u of n minus 4 minus u of n minus 16. Here u of n minus 3 means it will come from 3 to infinity, and u of n minus 9 means it will start from 9 to infinity. When we minus this both signals, it will be value will be there from 3 to 8, where our x of n is only 1 for 3 to 8. Same like that for h of n, u of n minus 4 will come from 4 to infinity, and u of n minus 16 will come from 16 to infinity. When we minus these both values, these both signals, we will get value from 14 to 15, where our h of n is from 4 to 15. Now by using the distributive property, we will solve this convolution. X of n convolution h of n is equal to u of n minus 3 minus u of n minus 9 convolution u of n minus 4 minus u of n minus 16. Now by using the distributive property, we can write this as u of n minus 3 convolution u of n minus 4 minus u of n minus 9 convolution u of n minus 4 minus u of n minus 3 u of n minus 3 convolution u of n minus 16 and minus u of n minus 9 convolution u of n minus 16. Now here we will use a shifting property. What is shifting property in convolution is, if x of n convolution h of n is equal to y of n, then x of n minus n naught convolution h of n minus n naught is equal n1 is equal to y of n minus n naught minus n1. By using this shifting property, we will solve this problem. Here if we see, all the signals are in u of n minus 3, u of n minus 4, u of n minus 9, u of n minus 4, u of n minus 3, u of n minus 16, u of n minus 9, u of n minus 16. So first we have to find the u of n convolution u of n. If we solve this u of n convolution u of n, we can solve this whole expression very easily. Now we will find the convolution of u of n and u of n. Okay, we have to find the u of n convolution u of n. For this, here x of n is equal to u of n, and again h of n is equal to u of n. For this convolution, step 1. First we have to find the x of k and h of k. We have to draw the graphs for both x of k and h of k. To draw the graph of h of k and x of k, just we have to change the time domain from n to k. So here the x of k graph will be 0, 1, 2, 3 and so on. Here the time domain is k and its all the values are 1. And for h of k, time domain is 0, 1, 2, 3 and all the values are 1. And the step 2 is we have to draw the h of n minus k, which is equal to h of minus n plus k. For this process, we have to first perform the time shifting, which is n plus k, and then we have to apply the time reversal for this n plus k, which is equal to minus n plus k. First we will perform the h of n plus k. For the h of n plus k, we have to shift the every time domain with n value. So we have to minus the n from this time domain, which is equal to minus n, 1 minus n, 2 minus n and 3 minus n, so on. This is h of n plus k. Now we will apply this time reversal operation for this h of n plus k, which is equal to h of n minus k. For the time reversal operation, we have to reverse all the value in origin domain, which the minus n will become the n and 1 minus n will become the n minus 1 and the n minus 2 will become the n minus 2. This is step 2. And the step 3 is we have to convolute these two signals. First we will see the case where n is less than 0. Here the first case we take is n is less than 0. First we will draw the x of k. X of k is from 0 to infinity, values 1. Here for h of n minus k, if n value is less than 0, all the n values will be negative, where these values will come from less than 0. So this total h of n minus k signal will be beyond the 0, for the left side of the 0. It means n will be there present here, n, n minus 1 and n minus 2. Here there is no common part between these two signals. They are not overlapping. So here when n is less than 0, y of n is 0. If we see the case 2 where n is greater than 0, if we see for n is greater than 0, first we will draw the x of k. For n is greater than 0, this signal will start from 0 and then to infinity, depending upon the n values. So this h of n minus k signal will come like this. Here this is the n value, this is the n minus 1 value, this is n minus 2 value, and then so on. If the n value increases, this signal will come to this side will increases. So there is some common part and there is the overlap between these signals from 0 to n value. So we can write y of n is equal to summation of k is equal to minus infinity to infinity x of k and h of n minus k. If you see here, this common part is only there from 0 to n value. Common area is only from 0 to n value. So this limits will change from k is equal to 0 to n, where x of k and h of n minus k both values are n, which is equal to 1. Convolution from k is equal to 0 to n, 1. We can write this as n plus 1. Total there are n plus 1 terms will be there here. So the value is n plus 1. The formula is k is equal to 0 to n up to 1 is equal to n plus 1. Summation of 1 from k is equal to 0 to n is n plus 1. The same formula will be there here, 0 to n to 1. So there is n plus 1 terms. Total n plus 1 will be the summation of this function value. So from the convolution we get that u of n convolution u of n is equal to n plus 1 for n is greater than or equal to 0, and 0 if n is less than 0. Here something is there when n is greater than or equal to 0. So we can write this as n plus 1 into u of n. So we got that u of n convolution u of n is equal to n plus 1 into u of n. Now we will use this property in our problem. If we come to our problem, here we will use this u of n convolution u of n is equal to n plus 1 into u of n. This is one of the important property which is also useful for our competitive exams. So all of you remember this property, which is very important. Okay. Here we have to use distributive property here. What is the shifting property? X of n minus n naught convolution h of n minus n1 is equal to y of n minus n naught minus n1. So by using this property we will get y of n is equal to x of n convolution h of n is equal to, see here, u of n minus 3 convolution u of n minus 4. Here n naught value is 3 and n1 value is 4. So by using this we will get substitute this y is n minus n naught is this one. If we substitute this n naught minus n1 in this, we will get n minus 3 minus 4 plus 1 into u of n minus 3 minus 4. This is first term. Minus, here n naught value is 9 and n1 value is 4. If we substitute this n minus n naught minus n1 in this equation, we will get n minus 9 minus 4 into u of n minus 9 minus 4. Here we use plus 1 here because n plus 1 is there. In place of n, we will substitute this n minus n naught minus n1. Here n naught is 9 and n1 is 4. Now we will same this for these two terms, plus here n naught is 3 and n1 is 16. So we will get n minus 3 minus 16 plus 1 into u of n minus 3 minus 16. And if we see this term, we will get minus n minus 9 minus 16 u of plus 1 n minus 9 minus 16. If we solve this, we will get n minus 6 of u of n minus 7 minus n minus 9 plus 4 13 plus 1 12, n minus 12 into u of n minus 13 minus here minus 3 minus 16 minus 19 plus 1 18, means n minus 18 into u of n minus 19 plus n of 9 minus 16 25 plus 1 24, n minus 24 into u of n minus 25. See, here we got y of n. Now here we will get some cases. First case is here n minus 7 is there, n minus 13, n minus 19 and n minus 25. n minus 7 will only come after n is greater than 7. It will start only from n is greater than 13. It will start from 19 and it will start from 25. For case 1. Case 1. If n is less than 7. If n is less than 7, these total terms are all 0. So y of n is equal to 0. And case 2. If n is between 7 and 13. Between 7 and 13, only these two terms will be there, and these two terms will be 0. First, n minus 6 into u of n minus 7. This will become 1. So n minus 6 will be there. n minus 12 into u of n minus 13. This will valid between this 7 and 13 region. In between 7 and 13, only this n minus 7 will be valid, and these three values will be 0. So here n minus 7, n minus 6 will be there, and n minus 13 it will become 0, and n minus 18 into u of n minus 19 is equal to 0, and then n minus 24 into u of n minus 25 will become 0. So the total value we got is y of n is equal to n minus 6 for n is between 7 and 13. Now case 3. If n is between 13 and here the next limit is 19. If we see here, n minus 6 into u of n minus 7 will valid. Here positive value will be there, so it will become n minus 6, and n minus 12 into u of n minus 13. In this region this will also become 1, so here we get n minus 12, and n minus 18 into u of n minus 19. Between this will not possible, so it will become 0, and between this n minus 24 into u of n minus 25, here this will be also not possible, so this will also become 0, because it will only start from 25, it will only start from 19, but the n value is between 19 and 13. So we will get y of n is equal to n minus 6 minus of n minus 12, which is equal to 12 minus 6 is equal to 6. So y of n value is 6 until the value is from 13 to 19, or else we can here take only 13 to 19, because it 19 it will also valid, so we will not take that case, so we can remove this. And the next case is in case 4. When n value is from 19 to here 25 is there, we will take up to 24. In this region, n minus 6 into u of n minus 7 will valid, so n minus 6. Here n minus 12 into u of n minus 13, this will be also valid, so n minus 12. And n minus 18 into u of n minus 19, this will also be valid, so it is n minus 18. And here n minus 24 u of n minus 25, this will be not valid, so 0. So total we will get y of n is equal to n minus 6 minus of n minus 12 minus of n minus 18, which will be equal to 12 plus 18 minus 6 minus 2n plus n, which will equal to 30 minus 6 minus n is equal to 24 minus n. Y of n is 24 minus n when it was between 19 to 24. Now we will see the last case. Case 5. When n value is greater than or equal to 25. If n value is greater than or equal to 25, this will be also possible. So we will write it. Now we will see the case 5. If n is greater than or equal to 25. Here n minus 6 into u of n minus 7 will be valid. So this value is n minus 6, and here n minus, what is the next thing? N minus 12 into u of n minus 13. N minus 12 into u of n minus 13, this will be also valid, so you will get n minus 12 here, and here n minus 18 into u of n minus 19. So this will be also valid here, so n minus 18. And then the last one is u of n minus 24 into u of n minus 25. Here this will be also valid, so the value is n minus 24. If we sum up with all the values, y of n is equal to n minus 6 minus n of n minus 12 minus n of n minus 18 plus n minus 24. If we add all these values, minus of minus 12 minus of minus 18, 30 minus 24 minus 60 minus 30, n plus n 2n minus n minus n minus 2n. This value is becoming 0 for n is greater than or equal to 25. So we will get, finally we will get y of n value as, first thing, n minus 6 when the n value is from 7 to 13, and then 6 when this value is from 13 to 19, to 18 here. It was less, we will less than or equal to 18. And 24 minus n when it was between 19 to 24. And 0 otherwise. In every other interval it will become 0. This is the final answer. Okay, thank you.